Okay, so welcome to the second lecture of this series where we explain the differential rules. In this series, or in this lecture, we're going to talk about product and division and exponent and radical rules. And then we will solve questions at the end of this lecture. Questions will be harder as we go on, and try to solve the question before I solve it. Okay, so let's start with our first rule, which is the product rule. Product rule is just two functions that are multiplied by each other. We have here, for example, f of x, the derivative of f of x multiplied by g of x. It's going to be equal to f of x as it is multiplied by the derivative of the second function plus the second function multiplied by the derivative of the first function. Does the order matter? No, it doesn't, because it's a plus sign. Okay, so let's do the first example. We have f of x equals x plus 1. G of x equals x power 2 plus 2x. We have here h of x equals f of x multiplied by g of x. Now what he wants is the derivative of h of x. This is the only time I'm going to write it in this notation, or just two times in this way, just to be visual. But I will just write it like this in the next examples. Okay, so we have h of x dash is equal to, or we have h of x is equal to x plus 1 multiplied by x power 2 plus 2x, right? We just put the functions now to differentiate this. We have h dash of x is equal to the first function multiplied by the derivative of the second function. So here this is the second function, which is 2x plus 2 plus the second function multiplied by the derivative of the first function. Here it's x plus 1, which is just 1, so you don't have to write it. Okay. To look on this example here, you can just visualize that this is a function and this is a function, that this is, for example, f of x and this is g of x. Okay, so let's solve this. So y dash is equal to the first function, root x, multiplied by the derivative of the second function, which is 2x plus 3x power 2 plus, okay, it's 2, so you don't have to write it, it's just 0, plus x power 2 plus x power 3 plus 2. You apply the second function, multiply it, 1 second. You multiply it by the derivative of the second function. Here it's a root, which is just 1 over 2 root x that I said the lecture before this. And 1 is just 0, so I don't have to write it. Okay, now we are going to look on the division. How, if a function is divided by a function, how to differentiate it. Okay, we have f of x over g of x. We want to differentiate this. Its rule is just squaring the denominator and putting the denominator, multiplying it by the derivative of the numerator minus the numerator times the derivative of the denominator. Okay, here it's a very important note the sequence here matter because there's minus, there's a negative. You can't put this before this. Okay, here I also wrote it in this notation, so it's clear. Okay, so here we have h of x is equal to x squared minus 2 over 2x plus 1. Okay, so now we want to differentiate this using the rule. So we have h of x equals, or h dash of x, because we're going to differentiate now, 2x plus 1 all power 2. Putting the denominator here, 2x plus 1. Multiplying this function by the derivative of the numerator, which is 2x minus, don't have to write minus, because this is just 0, minus the numerator, which is x power 2 minus 2, times the derivative of the denominator. And the derivative here is this, not this, because this is power 2. So just 2. Okay, now we have another example on the division rule. Now to differentiate this, we have y dash equals, applying the rule, in the denominator power 2, x power 3 plus 6 all power 2, and just putting the denominator here and the numerator, multiplying it by the derivative of the numerator, which is 2x plus 1 minus the numerator multiplied by the derivative of the denominator, which is 3x power 2. And because 6 is just 0. Okay, now we are going to talk about the exponent rule. The exponent rule is just anything power n. Any function power n. You multiply the function by n, the power, okay, and minus 1 from it. This is just like, if you remember this, x power 2 is just its derivative, it's 2x, right? Okay, now if you look at it in this way, if you're going to say x bracket power 2, if you look at it in this way and apply this, you can see it's 2 minus 1, which is 1, and the derivative of x is just 1, so it's just 2x, right? It's the same. It's just the same as this, but for more broad, like this example, and we will solve it now. So let's delete this. Okay, so now to solve this, we have y dash equal to, apply the rule, 3, the n, applying n, multiplied by the bracket as it is, plus x all power 2, and then multiplied by the derivative of what's inside the bracket, which is 2x plus 1. Now let's look on this example. This example can be solved by two ways. The division rule, where g of f of x is just equal to 1, and we will do this at the end of the video while solving problems. But now we will solve it by the exponent rule. So we have y, before doing y dash, this is equal to x power 3 plus 2x whole power -2, right? So -2 is just a number, n. So now we can solve it. So y dash is going to be equals -2, putting n down, x power 3 plus 2 all power -3, because -2 minus 1, -3, multiplying it by the derivative of what's inside the bracket, which is 3x power 2. And that's it for the exponent. Okay, now to look at the radical rule. It's just another form of the. It's a special case of the exponent rule, which when it's power half. Okay, it's a special case because you can always do it like this, but you can just solve it by the exponential rule if you want. The exponent rule. Okay. So if you remember, we have root x. When we differentiated it, it's 1 over 2 root x, right? Okay, what about if we have root x plus 1? Or no, make it x squared plus x. You're going to apply the same rule, this rule here, but let me do it. If y is equal to this, then this is equal to x power 2 plus x power half, right? So y dash, if we're going to apply the exponent rule, we have half whole power negative half multiplied by the derivative of what's inside the bracket. Now, if you look at this, it's just the same as 2x plus 1 over 2 root x power 2 plus x, right? Now, have a minute for yourself and look at this and look at this. There's a function here, we differentiated it here, and it gave exactly the same as doing all these steps. So now when you see this, you can just in an instant solve it like this. Now let's solve this question. We have y equals root of all of this. So y dash is going to be equal, let's apply the rule. We write 2, write the bracket. Let's write the root, sorry. X power 2 plus 2x plus 1. And now differentiate what's inside the root, beneath the root, the denominator, which is 3x power 2 plus 2x plus 2. And that's it. Okay, so now we are going to solve 9 problems, and they have a lot of tricks in them, so it'd be wise to watch them. Okay, now for the first question, we have this. In the exponent rule, I solved one like this with the exponent way, so let's solve this using the division rule. Okay, so using the division rule, y dash is equal to, we're going to power the denominator, or 2, so t power 3 plus 2t power 2 minus 1, all power 2. And now we will just put it in the denominator. Okay, just a note, this is just g of x, right? And in this case, f of x is just equals 1. So here we're going to differentiate 1. What's differentiation of 1 is 0. So all of this is just 0. Minus the derivative of this. Of course, we're going to apply 1 and you don't have to write it. Multiply it by the derivative of this, of the denominator, which is 3t power 2 plus 4t. That's it. Okay, now we have this example. Of course, when you look at it, you can just say it's a division rule, but there's a better way to solve it. If you remember this, I wrote it in the last lecture. It's expanded, right? You can write it here, x plus 2, x plus 2, x plus 1. So because 2 is just 2 times 1, and 3 is just 2 plus 1. So you can write it like this. So now you can see that x plus 2, x plus 2 are gone. Now this is just equal 1 over x plus 1, which is equal to x plus 1 power negative 1. So to differentiate this, you can just use the exponent rule. So negative 1, you just put the negative, differentiate, like power negative 2, you put it as it is, and power negative 2, because we minus 1, multiply it by the differentiation of what's inside the bracket, which is just 1, so you don't need to write it. Okay. In this example, I have an important note in it. This is a product rule, right? So we will solve it as a product rule. Let's solve it. If you have f dash of y is going to be equals to, just put this as it is, 1y power 2 minus 3 over y power 4 multiplied by the derivative of the second function, which is 1 plus 15y power 2. And of course here we have y, we are differentiating y, it's okay, right? You don't have to write it y dash here because now it's a dependent variable, independent variable. Okay, this plus the derivative, or the second, multiplied by the derivative of the first. So this is just 1 over y power 2 is just y power negative 2, right? And 3 over y power 4 is just y power 4 or negative 4, sorry. Don't forget there's a negative sign here, okay? Let's differentiate this. It's going to be negative 2 y power negative 3. Oh, minus, minus. So it's going to be plus 4 times 3 is just 12. Y power negative 5. Another important note here, if for example you are solving an MCQ question and you have your answers as brackets like this, so just leave it like that and it's good. But sometimes it's in the simplest form. So it'd be wise here to simplify one bracket before differentiating and then differentiating. It will be easier than simplifying two brackets, right? Or and the final answer for this in the simplest form, I'll just write it if you guys want to know. It's just negative y power negative 2 plus 5. Now, maybe try to expand these brackets, distribute them on each other, and then differentiate and see if you have the same answer. Okay, now this example is a very good example because it combines both exponent and the product rule. So let's solve this. We are going to use a product rule, right? So you put the first function as it is, multiplied by the derivative of the second function, which is 5x power 2 plus x plus 1 all power 4, right? Minus 1. And now multiplied by the derivative what's inside the bracket, which is 2x plus 1 plus. Okay, I should have wrote in here y dash equals. That's okay. Plus the second function, which is x power 2 plus x plus 1 all power 5, multiplied by the derivative of the first function, which is 4. You just write this as it is, power 3, multiplied by the derivative of what's inside the bracket, which is 2x. Okay. Oh my god, can delete this. Okay. And that's it for this example. Okay, now let's solve this example. I also like this example because it combines both the root and the division. As you see here, what's dominant is the root. An example for a division that is dominant, it's, for example, over root x plus 1. Of course, what's dominant here is a division. I will tell you an example on this, I think, at the end of this lecture. Okay, so y dash is going to be equal. Apply the root rule, as we remember it, to put the root as it is. Now differentiate the root, or what's inside the root, above here, right? So it's a division. X plus 1 all power 2. Now you put x plus 1 here, multiplied by the derivative of the numerator, which is just 1, minus the denominator, multiplied by the derivative of the denominator, which is also just 1. Don't need to write it. You can remove this x with this x if you want. And that's it for this question. Okay, now for question 6. It just looks like a normal division, but it can be even simpler. If you look at x power 3 plus 8, you can write it as x plus 2 multiplied by x power 2. Okay, about x power 2 minus 2x plus 4. And how to do that? This is x power 3, right? Plus 8. And do the third root for both. So it's x, and 8 is just 2. Now look at this bracket. X power 2, okay? To do the second bracket, x power 2 minus, change the sign here. If it's minus, make it plus. If it's plus, make it minus. So square, change, and multiply both these by each other, 2x, then square the last, or the second number. So to memorize it, power, change, multiply power. Power, change, multiply power. Okay, and over x plus 2, so remove this with this. So now you only need to differentiate this over here, which is 2x minus 2. Okay, now for this example, if you look at this, it looks like a product rule. But this here is just over here. So you can say this is equal to x power 3 plus 8. So when you see that the rule is applied in the both brackets, that x is squared, then the sign is changed, and they are multiplied, then the last term is powered, you can get it back to this form by doing power 3 to this value and doing power 3 for the other one. Okay, this variable and for the 2. So the derivative for this is just x power 3x power 2, and 8 is just 0. Okay, and this is an example for when the division is the dominant one, and there's another example after this, and we'll have finished this lecture. Okay, so y dash equals squaring the denominator, which is x squared plus 2x, squaring the root, which is just 1, right? And now things that denominator, this, not this, x power 2 plus 2x, multiplying it by the derivative of the denominator, which is just 1, minus the denominator, which is x plus 1 multiplied by the derivative of the denominator, which is just going to be 2 root x power 2. And now differentiating this, what's inside the root here. So it's 2x plus 2. Okay, now for the last question. This is just a division rule, uh, but I want to solve it in another way. Uh, it needs some experience. When you solve a lot, you will know it. This is just x plus 1 multiplied by x plus 1, right? Over. Oh, by the way, if you just applied the division rule, it's not going to be wrong. It's just that I'm giving tips here, right? And this is equal to x power 2 plus 2x plus 1 over root x power 2, sorry, plus 2x plus 1, or the third root. If you can see here, the base is the same, right? 1 second. You can see the base here is the same, right? For the powers, and this is what I mean, that x power 2 plus 2x plus 1 whole power 1, right? Multiplied by x power 2 plus 2x plus 1 whole power negative 1 over 3. So we know that if it's x multiplied by x to the power of negative 1 over 3, it's equal to x power 1 minus 1 over 3, right? It's the same base. So here it's the same idea, which is equal to x power 2 over 3. So now you can see that this is equal to plus 2x plus 1 power 2 over 3. Now you can differentiate this as an exponent rule. So y dash equal to 2 over 3 x power 2 plus 2x plus 1 whole power 2 over 3 minus 1 is negative 1 over 3, and multiply it by the derivative of what's inside the bracket, which is 2x plus 2. And that's it for this video.